With the given details, let's try to determine the standard form for an equation of an ellipse. To determine the standard form for an equation of an ellipse, we just need to determine three important things. Sorry, that's three important things. Number one, the center. Number two, the value of the A. And number three is the value for the B. Whenever we have these three items now, we can automatically create the standard form. Why? Take note that the sample standard form for an equation of an ellipse follows x squared over a squared plus y squared over b squared is equal to 1. Here, what we just need is actually the center. The center for this is at origin, but it could also become x minus h and y minus k. So center is really an important thing here. Second, the value for a and the value for b. Now for the value of a and b, we can determine it by the points of vertices, the foci, co-vertices, or even the lengths of the major and minor axes. Let's talk about number one. In number one here, we don't have the center. So it's x. We don't know what is that. When you talk about some of the distances from the foci or foci, this is actually another term used to describe the major axis. This is actually the length. This also means that that is the length of the major axis. I'm going to make some shortcuts so that we could just discuss everything thoroughly. This is also the length of the major axis. This is equal to 10. Okay? The length of the major axis is determined as a formula which is equal to 2a. Since the minor is 2b, again, my major axis is 2a, the minor axis is 2b. So with this, 2a is just equal to 10. Divide to both sides, a is equal to 5. We already have a already with this. Next is to look for b or the center. Again, the center is not given, but the foci are given. When you have this foci, take note that this foci lie on the same line containing the vertices and the center. If we're going to have a graph for that, I don't know if I have okay, I have not placed here a sample, just a assumption. Let's just use this. If sorry, if we have here the Cartesian plane and the foci is at 0, let's use pink because we used pink earlier in the previous video. 0, -4, 1, 2, 3, 4. Let's assume it's here. And you have 1, 2, 3, 4. It's also here. These two foci lie on the same axis as the vertices and the center. So the vertices will be somewhere here and here, but definitely the center is here. The center now is given to be at 0, 0. Why? Again, the foci, the center, and the vertices are collinear, or they lie on the same line. If the foci are here, it's impossible for the vertex to be present here, because if this will be accepted, then definitely they will not form a line, or they are not collinear points. So already have center, we already have A. How about for B? Now, the distance from the foci to the center is the value for C. But wait, are we asking for C or B? I thought we're looking for B. Of course, we're looking for B, but just by answering C, we can solve it later on using the formula C squared is equal to A squared minus B squared, as discussed in the previous video in your module. Okay, so this is the value of C. C is the distance from the center to the foci, and even the other way around. The distance is 1, 2, 3, 4. So the value for C is equal to 4. But it's not what we're looking for. We're looking for the value for b. Let me move my graph here. All right. So the value here is this. C squared, we have 4 squared is equal to 5 squared minus b squared. Okay. So we have here 16 is equal to 25 minus b squared. Subplus or add both sides by b squared. Okay. And also subtract by 16. You will have here the expression b squared is equal to 25 minus 16. And it's actually 9. And when you take the root of b, you will get positive negative 3. Again, b, a, and c are length or measurements. So we only accept b as a positive 3. This is the value for b. Okay, this is now your center and this is your a. So your equation will matter like this. Again, the form may be like this, okay? X minus h, the square of it, y minus k, the square of it. Okay, so let's have it here. Let's increase a little bit our length here and probably at the bottom as well later. Okay, so let's have our equation x minus h, the square of x minus h plus the square of y minus k, y minus k. This will be equal to 1. Why is it that I still place it this here unknown? Because I don't know yet whether I will place here a squared or b squared, or it will be b squared and then a squared here. My hint here is again, I will place a square depending on the position or the orientation. If the focus is here and the vertices are in this area, the ellipse will probably look like this. Not necessarily this form, but it will probably look like that. Because again, the vertices are part of the major axis. And then it also passes through, the major axis also passes through the center and the foci. So since the foci are placed here, it looks like this. So we are talking about the horizontal orientation or position of the ellipse. And if it's horizontal, the a squared is placed under x. If it's vertical, the other way around. This is where we will place b. So this is the standard form for number 1. And let's try to substitute all the values. So we have here x minus 0 as our center, and then squared over a squared, which is 5 squared, plus y minus k squared over, we have 4, no, not 4, this C pala, b, 3 squared is equal to 1. And simplifying the rest, you will have x squared over 25 plus y squared over 9 is equal to 1. This is your standard form. Again, the process involved looking for A, center, and B. Even if it's one of it's not is not given, analyze thoroughly and then apply the proper or the correct formula. Because if I'm going to interchange 25 and 9, it will not look like horizontal stretching. It will become a vertical stretching. Let's proceed to item number 2. And item number 2 will have the foci at 5, negative 3, and 5, 8. Right? And the sum of distances is still the major axis 2a. So 2a is equal to 16. So a is equal to 8. A is already given, but we're looking for center rather, and b. We earlier we used the foci to determine the center. So let's try to use the foci here. Okay, if I'm going to have here this real Cartesian plane, sorry, not real number line. if I have this Cartesian plane here for a while, okay, it's not straight, pardon. And then we have 5, negative 3. 1, 2, 3, 4, 5. 1, 2, 3. So the foci is somewhere here. And then we have another 5 as well, and 8. 1, 2, 3, 4, 5, 6, 7, 8. So it's somewhere here. The foci is from this to that. It would mean that the vertices is lying on the same line passing through this and the center as well. Because if I repeat, I'm going to use pink for foci. What did I use earlier? It should be like that. Okay. So the center is somewhere here, somewhere here. They lie on the same line. They should lie on the same line because that is the characteristic of the foci, the vertices, and the center. The center here will have the same distance from that area and here, okay? Because it's the center. This might not be the correct center. I'm just placing it where, but the center is somewhere here, having the same distance from that to that. If we say has having the same distance, meaning the center is the midpoint. May I repeat? The center is the midpoint of the focus. Again, the center is the midpoint of the focus. In short, we could use the formula for the midpoint. The midpoint is where you will add the x coordinates and y coordinates and average both of them. X sub 1 plus x sub 2 all over 2, comma, y sub 1 plus, sorry, plus y sub 2 over 2, and that would be your center. So x sub 1 for your foci, we'll use foci, okay? You have 5 plus 5 here, the 2, all over 2. And then y sub 1 is negative 3 plus 8. Pardon. When if I'm correct, I already changed this in our practice exercise. Sorry for this. Sorry for this. Okay. I have changed this already because it might become a fraction form. It will become a very big problem. So pardon. It's 5, 7 in our module. I already changed that. So 5, 7. Okay. Please be guided. Please take note of that. So you have here 7. So 3 plus 7 over 2. It's okay naman po if it's fractional, but for the purpose of illustrating this, I would like it to be very still a integer. So you have 10 over 2, and then you have here comma. Sorry, that's comma. You have 4 over 2. So the midpoint between the two foci is at 5 and then 2. And this is also your center, 5 and then 2. Again, the midpoint of the two foci is actually your center. So you already have your center, you already have your A. What you need now is B. If the center, okay, I'm erasing this so that I could actually change it again here. The foci is here and at the bottom. The center is at 5 and 2. It's somewhere here. Okay. The distance between the foci, any of the foci, and the center is actually equal to C. Again, the distance from any foci to the center is equal to C, just like what happened to number 1. We just counted them. So here, from foci, which is 5 and 7, 7, 6, 5, 4, 3, 2. Again, from 7, 7, 7, 6, 5, 4, 3, 2. How many steps did we make? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So the value for C is 5. I repeat, the value for C is 5. But looking at the second foci, from negative 3, negative 2, negative 1, 0, 1, 2, 1, 2, 3, 4, 5 steps as well. So this is the value for your C. This is what you need to get the value for B. And earlier, the formula for C is this. C squared is equal to A squared minus B squared. Let me try to move number 3 later. Okay, I'm going to move this somewhere here. All right. So C squared is you have here 5 squared is equal to 8 squared minus B squared. Again, add both sides by B squared. Add also B squared here. You will have the, and subtract 5 squared both sides. Okay, I subtract 5 squared both sides. You will have the expression here, B squared is equal to 8 squared minus 5 squared. Okay, because it will be removed like this and moved like that. Okay, so B squared is equal to 64 minus 25. Okay, so 64 minus 25 is 39, if I'm correct. Am I correct? 39, 64, yes. And then B is equal to positive negative square root of 39, or B is actually positive square root of 39. You don't need to worry about this because later on when you come up with an equation, you're still going to take a square of B. Okay, square of B. All right. So the square root will still be simplified. So here we go. The formula is x, little movement still here. Okay. The formula is x minus h squared. And then we have here plus y minus k squared. We have here the division is equal to 1. The final decision is to whether where do we place a squared and b squared. Looking at the graph, if the foci are here, the center are here, and the vertices, so it should actually look like a little bit like this. Not necessarily this one, but a little bit like that. So it's actually vertical. Vertical. So if it's vertical, a squared should be placed here and b squared on the other way around. Okay, so different from number 1. Okay, a squared here, b squared here, interchange. So let's try. And our center is at 5 and 2. A is 8. And then b is positive square root of 39. Let's go. So we have the value here. H is 5. You have x minus 5 square over square root of 39. That's your b squared plus y minus 2 as the y coordinate of the center squared all over a squared, which is 8 squared equal to 1. Finally, you will have here this equation, x minus 5 squared over the square root will be removed. That's 39 plus y minus 2 squared, that's squared, over 64 is equal to 1. Okay, so this is our equation for number 2. Oops. All right. Next, let's have the last item. But the last item, if I'm correct, would be easier. Why? It is easier, sir, because center is already given. Unlike number 1 and number 2, that we still need to analyze. In number 1, based on the given, that the foci in the center will be collinear. That's why it's 0, 0. But in number 2, we use the midpoint. Here, it's already given. So the center is already given here. The horizontal major axis is again your 2a. So you could solve 2a is equal to 20, a is equal to 10. And the minor axis is 2b. So 2b is equal to 16, b is equal to 8. In number 3, again, we already have the center. We have value for a and the value for b. And we can now draw or come up with a standard form. You have here x minus h squared plus y minus k squared is equal to 1. Where should I place A? Where should I place B? Look at the given horizontal major axis. When you say horizontal major axis, the major axis is on the horizontal. That would mean it's stretched horizontally, and the minor axis is the vertical one. This would mean that its position is horizontal, leaving A squared here and B squared for the other. And just substitute all the given. Take note that in the given, our h is negative 2. So don't forget to have minus negative 2. You have this form squared all over 10 squared plus the y coordinate of the center is at 6 positive. So you have y minus 6 squared over your b, which is 8 squared, equal to 1. Finally, the double negative property here will be done. You have x plus 2 squared over 100, that's 100, plus y minus 6, the square of it, is equal to 64, equal to 1. So it's a little bit easier since A and B and the center is here. The only difference is again the determination of the double negative property here, and definitely with the use of your position or orientation. This is the standard form for number 3. Please use this video as you start working on your worksheets. And again, the first chapter is on analytic geometry. It would mean that we always need to analyze our items. We still have one more video for ellipse, the next video, so please be excited. Goodbye, everyone.